Sampling techniques in research play a crucial role in ensuring that the data collected accurately represents the population being studied, making them fundamental to any scientific inquiry. Sampling refers to the process of selecting a subset of individuals, items, or observations from a larger population to make inferences about the whole. There are two major categories of sampling techniques: probability sampling and non-probability sampling. Probability sampling methods ensure that every member of the population has a known, non-zero chance of being selected, which minimizes bias and improves the validity of results. The most common probability sampling techniques include simple random sampling, where each member has an equal chance of selection, and researchers typically use random number generators or lottery methods. Systematic sampling, which involves selecting every nth individual from a list after choosing a random starting point. Stratified sampling, which divides the population into strata or subgroups based on shared characteristics such as age, gender, or income, then samples proportionally from each stratum. And cluster sampling, where researchers divide the population into clusters, often based on geography or organizational units, then randomly select entire clusters for inclusion in the study, making it cost-effective for large and dispersed populations. Another advanced approach is multi-stage sampling, which combines different methods, often starting with cluster sampling and then applying random sampling within selected clusters for better precision. On the other hand, non-probability sampling does not provide every member of the population an equal chance of selection, which makes it easier and less costly, but also more prone to bias and less generalizable. Common non-probability methods include convenience sampling, where participants are chosen based on availability and willingness to take part; purposive sampling, which involves selecting participants who have specific characteristics or expertise relevant to the research; quota sampling, which sets quotas to ensure representation of certain characteristics but does not rely on random selection; and snowball sampling, often used in studies involving hard-to-reach or hidden populations, where existing participants refer others from their network. Each technique serves a specific research purpose. For example, random sampling is ideal for surveys aiming for generalization, while purposive or snowball sampling is useful in qualitative research focusing on depth and context rather than breadth. The choice of sampling method depends on factors like research objectives, population size, resource availability, and the desired level of accuracy. Examples help illustrate these techniques in practice. A researcher studying student stress levels across a country might use stratified random sampling to ensure representation from different regions and educational levels, while a public health study on rare diseases might rely on snowball sampling to identify participants through networks since the population is small and scattered. Similarly, marketing firms often use quota sampling to ensure that their sample reflects the target market demographics, such as age, income, and gender ratios. The accuracy and reliability of research findings significantly depend on the appropriateness of the chosen sampling method, as biased or poorly executed sampling can lead to misleading conclusions. Moreover, researchers need to consider sample size because even a well-chosen sample cannot yield valid results if it is too small to represent the population. Statistical formulas and software tools are often employed to calculate the required sample size based on the desired confidence level and margin of error. Sampling techniques are not just technical steps, but strategic decisions that directly impact the credibility, validity, and generalizability of research outcomes. Understanding both the strengths and limitations of different sampling methods allows researchers to select the most suitable approach for their specific study design, ensuring that results are both accurate and practical for real-world application.